Hello, and thanks for coming in. Thanks for the interest. I'm going to talk about the download redirector that OpenSUSE employs. And even though this is a generic project or generically useful piece of code, which could be employed by other projects too, I'm talking about it with some OpenSUSE context, because that's where we use it. And I hope it's nevertheless understandable for you. If I talk too much about OpenSUSE specific terms, then don't hesitate to interrupt me. To introduce myself, I have been working with SUSE for 8 years now, working on the download infrastructure and also on the build service. And in the past, I have been doing a lot of Apache maintenance. So I'm always a bit into web stuff. So what do we serve by OpenSUSE? We have lots of products like release distributions, Gen 1, Gen 2, Gen 3. Then there are unstable snapshots, several architectures. Then there are sources, bug infos, test trees, other test trees, and then the build service since recently, which adds a lot to that. So that's all. Doesn't sound too bad, does it? But this is really much. Altogether, we find 700,000 files right now in the OpenSUSE tree. And just to stud all those files takes a long time, as you can guess. And the size adds up to a total of nearly a terabyte. Meanwhile, and we also have lots of download requests to that stuff. So, well, doesn't sound too bad, does it? The problem is there's no single big fat pipe which can handle that. Nobody has such an internet connectivity. And there also isn't a mirror which can handle that much stuff. I have a quote here of a mirror which basically says, isn't that a bit heavyweight? Debian and Ubuntu is just 200 gigabytes. So naturally, the commonly used solution to that problem is employing a content delivery network. There are lots of them, and they can handle that, but they are dead expensive. It's not really a question for us, because we can maybe afford that for 1 or 2 days a year. So it's not a solution for us. So we will need some kind of poor man's CDN. This is basically what we're trying to build. Luckily, mirrors come to help. Thinking about mirrors, it's interesting to know that they don't cooperate with us in any way that we can control them, have control over them, because they just mirror us for their own benefit. Some making a business with it, some also want to help us, and they simply mirror us if we want it or not. We have not much influence. What we can do is we can facilitate mirroring for them, which is in our interest. In the past, the mirrors used to be equal, and they used to be equally useful, because they were either mirroring us or not, and so if a mirror was mirroring us, you could, and fast enough for you, close enough to you, then you could simply use it and stick to it, and just do everything over the mirror. But today they are really different against each other, because they don't mirror the complete trees. And for users, it has become impractical to just pick one mirror and then stick with it forever. So with all these trees that we offer of that size, there's virtually no mirror that can mirror that completely. So there are no complete mirrors. Most mirror only some parts. Or mirrors can also be outdated. Maybe they don't have caught up and mirror already released products. So what we see is partial mirrors. And really only few sites will actually mirror a terabyte of stuff. It's actually even hard to find anyone just for mirroring the build service capabilities, which are 200 gigabytes. Not even the largest SourceForge mirror has capacity for that at the moment. I mean, they have lots of capacity, but they don't have enough free capacity right now to add this to their mix. So we see partial mirrors. And if that wasn't enough, our content also has an extremely high turnover rate, because it's not a tree that's released 3 times a year. Because we have a build service and security updates, and they are released basically all the time. Could be every few minutes that packages are new packages turn up. So that's actually faster than it can be synchronized, in fact. Because during the sync, it's already famous. So a mirror is immer some kind of unsharp picture. So we have no up-to-date mirrors in reality by definition. So what we have are partial mirrors. So what can we do with them? Before the answer, another thing which makes it even more complicated is that with the open source binary package that we offer for download, those packages are referenced in metadata. And this metadata contains checksums and cryptographical signatures. So if there's something wrong or packages come from wrong version from some mirror, then the client will trip over it. So back to the question, what can we do? One thing would be maintaining mirror lists and trying to keep them up to date, but that's extremely hard to maintain. They are too static and they are never ever correct. So mirror lists would work to some extent for human users, because if a human user downloads some ISO images, then that's maybe 2 or 5 files. Then it's possible for the user, or feasible for him, to try 2 or 3 mirrors and then find out which one works for him. But it's still annoying. The mirrors are out of date, which they are. And this trial and error process leads to or can lead to some effect which can be called SourceForge effect, because that's what happened to SourceForge 2 years ago. People will, in the process of finding the suitable mirror, they will all end up with one mirror and trying to use the same mirror, because that's the one that has given them the least headache. So at SourceForge, every user after some years went to the Irish mirror. So problem for them. But it will make mirrors overused, so they're not really good then anymore. So there is one solution which is highly dynamically generated mirror lists. So they virtually need to create it in real time. And even though we can't execute any control on the mirrors, we can watch them carefully and see what's there. So that's what we are doing. So we redirect clients to mirrors. That's what the redirector is about. And in order to be able to do that, we need to know what the mirrors have. So what we need is an inventory of files, and a file list of each mirror, which we need to keep up to date, which we do by scanning them and Then we need to periodically probe the mirrors if they are online at all and alive. And with that in place, we can redirect the clients, HTTP requests the clients do, to mirrors. And this is something that works with every standard HTTP client, so it doesn't involve any specialized client. And while we're doing that, we have the opportunity to locate the client, see where it is located, in which part of the world, by way of its IP address. And we can load balance the requests based on mirrors capabilities. So we can have read mirrors and send them less requests if we know those mirrors. We also have the opportunity to do sensible, to enable sensible caching of content, because caching is always important because it frees the lines and saves bandwidth. And but we need to exactly set cache control headers for that. But that we can do that because it works with our. We do it on our own. The requests go through our infrastructure. We can also decide to deliver certain files directly instead of redirecting. So that gives another level of control. And that's why we actually use only HTTP, not FTP, because FTP is a bit too stupid and can't have no way of cache control. Web caches cache arbitrarily, like 6 to 24 hours roughly. So the inventory that we need is obtained by scanning mirrors, which we do by parsing mainly, or fallback to slow because parsing is not available. The inventory is kept in a database, and there's an interesting characteristic of this inventory. When we sync out stuff, new stuff to servers, then old stuff becomes obsoleted and files are deleted on the mirror. In the database, in the inventory, the stuff will only disappear with the next scan, when we do the next scan of the mirror. But this is not a problem for us because the files disappear first on the master itself. So once they are gone there, then we don't need to redirect for them or deliver them. So there's actually no need to look up in the inventory. It will be cleaned up later, but it doesn't matter. The whole idea was, to my knowledge, first implemented and thought out by Christoph Thiel, actually presented here 2 years ago. It didn't scale very long, because first it was only used for some parts of the distribution, but when you tried to use it for more parts, then it wasn't scalable enough. It was redesigned a year ago and rewritten as an Apache module in C, which is called mod Zircablo. And there are some similar frameworks which have similar approaches which also inspired the design. So if you wonder about the name, which nobody can pronounce, memorize, and so on, I came to the name because during the time I thought about this stuff, I visited Slovakia and I went to a concert in this location, which is called Klub za Zrcadlom. And later I learned that this means behind the mirror. So it seemed like some kind of maybe possible name. So how does it work? I'll give you some step through here. The redirector first looks at the file can or should be redirected at all. Then it cleans up the file name because usually there are lots of symlinks in the trees, so you would end up with lots of double files in the database. So we can utilize the file name and just ignore symlinks. Then the redirector looks up country and continent of the client. Then it looks up possible mirrors for that client and somehow sorts them by distance. Then it also makes note of previously used mirrors by that client. So it memorizes the kind of association between previously used mirror. And after the local mirror or the mirror from the country and the preferred mirror, it will next look at the mirrors from the same region and then at the rest of the world. So it sorts them. And after that, from the best available mirrors, it chooses one by random. This random choice is also influenced by some kind of value that we define for each mirror, which gives them greater or lesser chance to be picked. Then it sends the client away with a redirect, or it may serve the file directly if no mirror was found. So this regime has lots of advantages. Those redirects are very cheap, so it's probably scalable. It is very integratable into web services because it's transparent. It gives you control when to redirect and when not. So this is maximum control that you can have or want to have about how the stuff is served. It proved to be very scalable. During last year when we released the last product, we had no problems at all. So it was so solid that I could actually go into vacation and no phone rang. Other advantages are that the centralized approach gives us the opportunity to count downloads. And it's also possible to integrate a real content delivery network, some kind of a wildcard mirror, which is always added into the mix, which we also did with the 10.3 release. And then there's something special. We can serve live mirror lists instead of redirecting. So that's the kind of real-time mirror lists I talked about. So the client can actually get a list of mirrors and then figure out by itself which is the fastest or So all this makes small and partial mirrors useful for us. So in fact the times that we need large mirrors, powerful mirrors are actually nearly over because we won't find a lot of mirrors that mirror the extremely huge trees that we offer. So what we actually need and what we can have is lots of mirrors which are not loaded with 1 terabyte, but only maybe 60 gigabytes is enough. So if we just mirror the most popular 10% of content, then we are fine. We can have more mirrors, and everybody's happy. And one of the best advantages of the thing is that it's not OpenSUSE specific, so it can be used with other download services. Disadvantages are that mirrors die without warning. Mirrors break all the time. It's just natural. And the reliability of the entire framework is only as good as the past. So what we do is we monitor the mirrors as closely as possible, and if one mirror fails, then we disable it automatically in the database and stop redirecting to it and check back later. But there's a certain time window between the time we detect the failure and actually disable the mirror, because we can't check it all the time. And there's also always weird failures which are very hard to detect or find out, like firewall problems that you only can find out about after 2 or 3 weeks of debugging, and with things that sometimes don't work, but they work most of the time. And here's some interesting potential for the OpenSUSE download client, because it could make use of the mirror lists and actually fall back to other mirrors. It's also important to know that with this kind of infrastructure, every request runs through the central server. So this server needs to be up, and so it needs to be high availability setup with proper load balancing and backup servers, and you can spread out several of the redirectors. That's not a problem. It's mostly, at least for us, more problem of the budget, because we still have only a single machine for that, but I hope that will change in the future. So it's not a design problem of the redirector, it's just a budget problem of the hardware that we have. But other than throwing hardware at it, for us it's also possible to enhance the client and make it use previously used mirror wireless. So this is my call to the OpenSUSE folks. I hope we can implement that in the future. Downtimes, in general, are often acceptable for human users if they don't occur too frequently, but they are often very bad for machines because software acts up and users don't want to deal with sort of error messages. So I think we really should make sure that the client has, our specialized client has special support for dealing with failures and falling back to mirrors. I'll step through a bit quickly here because I actually already mentioned that and I want to save some time. I could expand on a number of optimizations that we did during the process of setting this up. So it involves some database optimization. It's crucial that it's scalable enough. And other optimizations are that we try to deal or try to respect certain mirror needs or special needs for remote regions like New Zealand that have special internet connectivity. So we have special support for that. To give you some numbers, download OpenSUSE.org, which served our last product release in autumn last year, by 13 gigabytes per second delivered content to clients, and that was only the content that we redirected to the network, and what we redirected to mirrors is not even counted here. And as you see, we have several million requests each day. I'll probably not discuss the other approaches in detail now because time is running out. There are some other things like Squid. It would work well, but requires Squid, which won't happen probably. Real content delivery networks work by adding intelligence to standard DNS. We had the static mirror lists, they're not longer feasible. There's a similar module like Mozilla Handler, but it requires interaction with the mirrors. The Mozilla project has a so-called bouncer, which is basically a similar approach, and the Fedora approach is also very similar, and with the difference that they have logic on the client and on the server side, so that works together. We like it so far. So what we have with the current setup are that our trees are big, and we need to think about splitting them up more, and at least offer more fine-grained, well-thought-out housing modules for the mirrors to mirror from, like the 10% most popular stuff I mentioned. And we need to make sure that we don't just put more stuff into the trees and it's blindly mirrored and just fills that disk. We need to improve our infrastructure. I mentioned it already. We need to do better monitoring and better failure detection. And we have still some old infrastructure left, like the mirror lists that were maintained in the OpenCC wiki, which were pretty static and edited by people. They are not simple enough to the system really. There are certain ideas which I will skip now. We can talk about it if you're interested. And I will thank you for listening. And ask me if there are any questions. In the remaining time.
How do you currently determine if a mirror is dead, or what is your criteria for declaring it's dead?
We check value every 3 minutes with an HTTP request on the base URL.
Okay.
So we would like to improve on this by checking real files and like random file downloads, things like that. And we need to expand on checking for large file capabilities and things like that. So there's a lot of potential.
Did I get it correctly that you also have some algorithms in place that do kind of load balancing, that you don't always redirect to one potential mirror and this one gets flooded because of client's partner?
Yes, so that's a weighted randomization that we do, and we give the mirrors a weight individually, and so by that we can make sure that a small mirror only gets very few requests, but it's still useful, and a small mirror might get more requests than for files that only this mirror has. So this can play together. We also have, related to that, we also have a way of making sure that a mirror in, say, Israel only gets requests from Israel. Or a mirror in Australia is a preferred mirror for clients in New Zealand. So, because they mostly go to Australia. So it's not helpful to them to do them around.
But that's knowledge that you have to enter manually.
Yes. That's hardly possible to obtain. It would, some things might be possible to find out by client feedback. Client would give us feedback about mirrors that work well for him. So there's also potential.
Yes. Maybe just ping times, or if you need trace route from the client, how many hops, and feed this back to the master.
It's difficult because we don't know the kind of connection.
Are you ready to have plans for third-party repositories like Pacman or something?
Good question. I think I haven't thought about it. We can talk about that to the build service folks. It might be problematic because of files that we may not be allowed to leak to, but for other stuff. But right now, the implementation expects the files to be there locally. So that helps us a lot for determining if a file is, if it's useful to redirect it, if it's fresh, if it can be cached and stuff like that. So it might be difficult.
Okay, basically with Pacman people could set up their own redirector.
Definitely. Yeah. So any other questions? Doesn't seem so.
Otherwise, Peter is of course also at the booth. If you have any questions, just come to the booth and discuss.
Thank you very much.
Thank you very much.